Imagine all the things you could print if you didn't have to worry about print size or the colors or materials you wanted to use. Imagine what truly uncompromised printing looks like. Basic printers let you turn your ideas to life, sure, but what if you want to print something bigger? Well, then you buy a bigger printer and are forced to wait longer to get your parts. What if you want multiple colors or materials? The existing printers can accommodate that, but at the cost of changeover time and wasted filament. What if you didn't have to compromise? What if you could print large objects in the same amount of time as small ones? Use multiple colors or materials with no changeover time because the printhead is already ready. That's where this printer comes in. A multi-head, simultaneous, independent, Core XY UV AB CD printer. It's taken me months to get this to the point I wanted to share and multiple failed prints and headaches, but here's the journey of how I built it and how you can get one yourself. The structural parts are made of carbon fiber rod and extruded aluminum, cut to size. The bulk of the rest of the parts are all 3D printed. There are quite a few of these, totaling 83 unique parts and just over 10 kilograms of plastic to print them all. The remaining items are all off-the-shelf components, most of which can be sourced via Amazon. I'll be honest, it is quite intimidating when laying all the parts out, but the satisfaction of putting it together quickly overtakes that feeling. The frame is sturdy and held together with a combination of metal brackets and plastic brackets held down with sliding and locking fasteners. The rails atop the frame are loaded with stages whose gantries span the slightly expanding rails, allowing them to nest within one another. The print bed is made up of three 410 by 410 mm heat beds. This enables efficient overlap and collaboration across the long direction. The motors in the front have corresponding pulleys in the rear, which establish the layered 3D maze of Core XY belts. The belts are wrapped around and driven by the motors, and the H-like shape allows the motors to move the printheads quickly, since most of the weight isn't on the printhead. Placing the last loop completes the motion system and leaves this pretty neat web of belts. My original design for the print beds involves a fully printed support structure, which isn't quite flat. The leftover carbon fiber rods seem to improve this significantly. With a few printed parts to hold them together, I can assemble and replace the frame, which leaves a much flatter work surface. I selected the Duet high current CNC electronics boards for this project, which require all the wires to be terminated in connectors. Wiring up the board to power and throwing on a basic configuration script, I was able to get motion. The boards are driven off of a very convenient web interface. The wiring for this project is a bit involved, with many of the off-the-shelf parts needing their wires extended in addition to having their connectors crimped up. With 4 stages, each with an extruder, 2 fans, a hot end, a thermistor, and an end stop, as well as 8 XY motors and 4 Z-axis motors, the wiring got somewhat tedious, but with enough music and patience, it isn't too bad. The X-axis end stops are slightly elongated to clear the Z-axis lead screws and contact the leftmost rails to 0. The Y-axis has end stops that are offset in the front of the printer to allow each stage to 0 without collision. They also set the minimum distance between stages. With just over a dozen 2-meter long wires extending from each head, wire sheathing was a must. The wires then feed over the side of the printer and plug in neatly to the Duet boards. At the rear of the printer are 2 high wattage power supplies, which should both be able to work off of a single US wall outlet. Belt tension is important to keep the motors from slipping, so I printed out some test tensioners and installed them, which were sufficient enough to let the printhead make circles without slipping. Loading in some filament confirms the wiring was correct and that the printer can heat and extrude. For the first print, I simply loaded a Benchy into a standard slicer for a 410mm square bed and pasted it into the Duet software. The defaults in the G-code were in millimeters per minute, and this printer needs millimeters per second, so we get this very slow printing. Multiplying the values by 60 at the top of the G-code let the printer actually print. The belt tension still needs improving, as we were skipping steps and drifting the layers. When it doesn't skip, it prints fairly well. When it does skip, well... For a first print, it was okay. You can at least sort of tell what it was supposed to be. I improved the design for the tensioners and affixed them to the rear of the printer for ease of access. Unfortunately, my attempts to tighten the bolts and increase the tension sheared through the rear belt pulley mount. This piece is a rather structurally important piece, so orientation and full infill are important. The improved tensioners work wonders at stopping the drifting. It also helped that I increased the total allowable amperage within the configuration file to be closer to the motor's rated current of 2 amps instead of the 40% cap that they were set to. Those changes, however, did nothing to fix the filament I had accidentally broken within the very long Bowden tube. Whoops. Fixing that revealed bed adhesion is a problem. But hey, what was just a pile of metal a few minutes ago is making things. It also looks like the other rear pulley mount is failing, which I should have seen coming. Another full infill print should fix that. There we have it, our first benchy. Print quality leaves a bit to be desired, but we can work through that. Circling back to the bed adhesion problem, it appears that the carbon fiber tube frame is still not quite rigid enough and creates considerable bowing in the center of the bed, furthest from the Z-axis lead screws. Measurement reveals as much as 4 millimeters of deflection, which simply won't do when trying to have these printheads work together. We can reinforce the bed frame with the leftover 40/40 extrusion. Cutting to length and printing some structural clasps let it attach to the bed. To clean up the wire routing, I printed a containment plate. To it I added a cable column and a wire cage to keep the wires from sagging onto the print bed. I then printed the remaining tensioners for the other 3 print heads. The relative heights are offset to prevent collisions across belts. Staggering their order further aids with this. The bed springs I had were not nearly strong enough for the weight of the 3 large beds, and get replaced by these high stiffness yellow ones. To affix the electronics and take them off my carpet, I printed mounts which hold both the main board and the expansion boards just off of the floor and on the frame. The hectic wiring quadrupled with the addition of the wires for the other 3 heads. Additional expansion boards and their mounts receive those wires and this Wi-Fi adapter, which allows me to stop needing a long Ethernet cable to communicate. For the boards to talk to each other, they use a CAN communication, the wires for which need to be the high-speed kind, and not the cheap phone wires that I happened to buy. With over 100 wires and most of them looking the same, labeling them was the only way to keep anything straight. To heat the beds and not overload the wall outlet, I have the print beds on individual solid-state relays, allowing for sequential heating routines. Placing the remaining wires into their channels and wire cages cleaned up the look considerably. Plugging in a power strip with both power supplies and the Wi-Fi adapter reveals that my wiring was all correct and everything glows appropriately. By configuring all 4 heads as a gang tool, I am able to move them all together in unison. Wire sheathing helps to declutter the drive axis motors on both the right and the left sides. The Bowden tubes still need to get cleaned up, but a handful of zip ties allow me to reduce the rat's nest that is these wires. These filament dryers neaten up the Bowden tubes and should allow for the printing of most engineering materials. Multiple heads require a custom homing script to dial everything in. To do this, I have various steps that drive all the heads as a gang tool and then pivot to a singular head movements for fine zero. In the long axis, which I call Y, the printheads home sequentially, front to back. This ensures that they don't collide with one another. To collaborate, the printheads are going to have to all be roughly the same height. Unfortunately, head 4, the rearmost, is going to begin its journey being the problem child of this build. While paper slides freely under the first 3 heads, number 4 dropped to contact the bed. At such a large span, this printhead's carbon fiber rods bow just enough more than the rest to cause issues. To procrastinate the problem while I thought of solutions, I began writing the slicer for this printer. If I wanted to print anything collaboratively, I was going to need a custom solution, but I'll get into that more later. Powering multiple beds and relying on the Duet's fuse seemed like a good idea, but the initial surge of current fried the fuse. Luckily, they sell replacements, in packs of like 25. I don't really want to keep doing that, so let's give it a dedicated fuse. This kind worked well for my filament recycler project, so let's try it here. The power runs from the power supply through the fuse onto the distribution terminals, which supply the solid-state relays with the opportunity for power. Each relay is controlled by wires from the Duet board, and the other side feeds up into the beds. It seems that this being an AC fuse for a DC system creates problems because this wire gets quite toasty. Why do I always have the most difficulty with the safety systems? This 20 amp DC circuit breaker should fix that problem and let me reset it if I somehow trip it. Wiring it in and checking currents, it seems that I just misread the very confusing Chinese instructions for these solid-state relays and needed to swap which wire went to which. With that sorted and this circuit breaker in place, the correct current is going to the correct spots now. To get this to work with Duet was a bit tricky. I wrote a daemon program which checks for active beds and cycles between them to reach the set point. The daemon monitors the system and ensures that only one heated bed is on at a time. The clock speed is a bit slow, so at startup there can be a brief few second draw to multiple beds at once, but nothing the system can't seem to handle temporarily. The relays also light up when they're on, which allows for a visual real-world gut check. Circling back on printhead 4, I found that I could simply add another support point on head 2's rails, and that created enough rigidity to solve the bowing problem. The orientation of the wire gauges needed to be made vertical to afford them the motion they need without blocking the motion of the other heads and without touching the belts. With that solved, let's load up the Benchy print on the Gang tool to make 4 at once. Belt tension on the rear heads is clearly not quite dialed in yet. Regardless, the printer has made 4 Benchy-esque parts of varying quality. Investigating the belts further, it seems I fastened them too loosely, and with the belt facing the wrong direction within the clasp, which led to slipping. Multiple points along the printer are going to need to be updated. With that fixed, let's see what happens to print quality. Getting better, but still not what I want. I think that the quality issues are coming from the printheads being so long. If I consolidate the mass higher up, the print quality should improve, not to mention we'll gain Z volume. Printing it out quickly reveals the difference in size. The pieces rest much higher and more fully on their support rods. The nozzle tip ends up significantly higher. The increased nozzle height forces a redesign of the Z-axis limit switches. The first one attaches nicely, so now to do it 3 more times. The motion looks better with less wobble. I noticed that the electronics can get a bit warm during printing, so let's cool them down. A few computer fans with printed mounts let us cool the top drive motors and the lower electronics. The fans work nicely, and a mounting platform for the bed control stuff with its own fan helps to keep that tidy and cool. Loading filament with my hot end adapters has been a pain, so I improved them to be more sloped, which more easily guides the filament into the extruder. And with those, I'm extruding again in no time. Printhead 4 was in need of some lubricant, so I had it sit out this print, but this was looking very promising. Unfortunately, I had once again broken my brittle filament in head 1. Aside from that and some stringing, phase 1 of this printer is done. If you've gotten to this point and you're thinking, wow, this is really cool, I want one, I have good news. If you head over to my website, bowler.llc, under the project tab you can find the bill of materials to make it yourself and support the channel. I also link some of the tools I found helpful. I have full build instructions, wiring guides, and configuration code for the Duet for sale as well. All the personal use STL files and a preloaded 3MF Bamboo Lab print file are also for sale. On an X1C, it's about 12 days of continuous print time and uses just over 10 kilograms of PLA. I have these items discounted until the end of 2025, so act now if you want a discount. If you don't have a printer or tools, I have links in the bill of materials where you can buy the parts and, in some cases, support the channel in doing so. As of now, the quoting process for those is a bit manual, but I'm working with them to try to streamline that. Obviously, there's a lot more potential for this printer, and as it grows, I will continue to add upgrade kits to the shop. I have made considerable progress on the collaboration mode and want to work on multi-material printing and supports next. Let me know what you think in the comments, and what ideas you have for ways I can improve it or what I can make with it. Subscribe so you don't miss those updates. See ya. Sorry this video has taken so long to put out, but I wanted to do this right so that I could make it available for you guys while also protecting the design via USPTO patent pending. So thank you for your patience, and I hope you all like it, and I'll see you in the next one.